Hey everybody, welcome back to Jim's Garage. If you've clicked on this video, then you're most likely in the position where you're considering getting a NAS. You're either thinking of buying one, or you're thinking of doing it yourself. Well, in this video, I'm going to show you how you can build your own NAS, how to install one, how to configure it, and in future videos, it's going to play a pivotal part in the rest of our home lab journey, as we will be mounting files directly from our network shares. So let's roll that back and talk a bit about what a NAS is and why you should consider getting one. So a NAS, quite simply, is network attached storage. It's some storage that's available on your network, i.e. it's not on the system that's running an application, it's somewhere else on the network. And that's really useful because you may have smaller devices, things like a Raspberry Pi for example. You may have a budget machine that simply doesn't have the storage requirements that you need. The beauty therefore is that you can have access to said storage over the network. That allows you to centralize your storage, and that will often give you benefits in terms of density, cooling, server racks, all those sorts of things. So why would you want a NAS? Well, a NAS plays a pivotal role in your 3-2-1 backup strategy. What's a 3-2-1 backup strategy? Well, it says that you need 3 copies of your data, you need 2 of those to be remote, and you need 1 of those to be off-site. So what does that mean? It means 2 copies on your local network. That could be a USB stick, an external hard drive, as well as your NAS. You could argue that if you were running your data in a RAID configuration, you would have a couple of copies of your data. But remember, RAID isn't a backup, RAID is for redundancy. Let's just get that right. And then you would want to back that up off-site. Now, I'll be doing a video later on about how you can back up your home lab and restore it seamlessly, etc. But obviously, in terms of backups, you want something off-site in case an act of God or something cataclysmic happened. I don't know, your NAS was stolen, your house was broken into, your house burnt down, your house flooded, all of those sorts of things. We want to have at least 1 copy that's off-site to mitigate all of those risks. So what are some of the options? Well, you can do the DIY, and that's the route that I chose after I'd purchased off the shelf. So there are lots of off-the-shelf products. Synology are one of the big brands, QNAP are another, and those are really good devices. But this is home labbing, right? So we probably want to do a DIY approach. Do go and check those out though, if you don't feel comfortable with a DIY approach. They are good, you pay a premium for the convenience, but you do get some performance from that. Just bear in mind that upgradability is going to be limited, certainly in terms of the number of drives, and you're basically fixed with the CPU. You might be able to upgrade the RAM. Some of the more advanced ones may even have a PCI slot, but we're getting too far into that. Let's go down the DIY route. So how much are we talking here? Well, you'll be surprised. You could build a compelling NAS for a small setup that isn't going to have crazy amounts of redundancy. Let's say a couple of drives, maybe with a couple of terabytes. You could probably do that for less than $200. About £250 over here. We pay a bit of a premium. So what am I talking about there? Well, any old sort of workstation on eBay, for example, or any parts you might want to acquire online, anything you have lying around in the house, all of those are probably going to be pretty good options. Now, bear in mind, a NAS typically will want to be on 24/7, so efficiency is a concern, as well as the age of the device, i.e. the older it is, the more likely it is to fail. And let's be honest, we don't want something that's going to be housing our sensitive data to crash on us. So in terms of horsepower, what are we looking at? Well, I used to run my NAS with a cheap dual-core CPU, and that's what I'll be using in this video. I teamed that with 2 4GB sticks of RAM, giving me a total of 8, which is, spoiler alert, that is the minimum that TrueNAS requires. It was a cheap, old, commonly available motherboard, just a consumer 6th gen Intel motherboard. And I put that in the cheapest case that I could find. And I paired that with 2 1 terabyte hard disk drives. And the whole thing came well under £200. And that was great. It didn't give me masses of storage. Don't expect to be backing up the whole archives or movie collections, etc. But it did give me the space to back up all of the containers, all of my personal documents, all of my family's personal documents, etc. All the things that if I sat down and considered it were really important to me. And that's kind of where I want to get you to. So I gave the game away earlier. We're going to be using TrueNAS. There are other solutions, things like Unraid spring to mind. But the reason I like TrueNAS is it's free and it's scalable. And I've never had a problem with it. And I know a lot of people in the home lab community swear by it. Now, we're going to use specifically TrueNAS Scale. I'm not going to get into that too much, but that is effectively a hypervisor as well. We're not going to use it for that. We're not even going to build it so that you could do that, i.e. it's not going to be powerful enough because we're working on a really tight budget here. But just know that through this config and installation, you're going to have a NAS that is going to be, for most parts, more than what you will need, and importantly, is something that you can upgrade in the future. The beauty is you can download your config files and simply upgrade your hardware and then import the backup. I've done that a number of times. There is an option to run TrueNAS virtually. People do that. People do say it's fine, but I don't recommend it if you're a beginner or you're using consumer grade kit. So I'm not going to support any questions that come in on that. The reason being that the more you put on your Proxmox host, the more likelihood something could go wrong. And as I said before, our NAS is our backup. We don't want it to go wrong. So let's get on to the build. So I'm joined here by my lovely assistant who's going to demonstrate some of the parts that we're going to use. So this is an old case. I demonstrated this in my first prologue video. It's just a cheap Cooler Master case. The drives that I'm using, this was rescued from a Virgin TV box. I have a couple of those lying around. You could use any spare drives that you've got or pick up some cheap ones that I showed earlier online. You could use SSDs if you want. These aren't great SSDs because they don't have any DRAM. I did show the MX500s previously, which are a decent SSD with decent performance. The CPU, just a really cheap dual core CPU from a few years ago. You can pick these up for dirt cheap online. It's not going to give you masses of performance, but we're just keeping this as a bare bones NAS. The RAM I'm using is pretty speedy. It's 3200 MHz RAM. It's Corsair Vengeance, and again you can pick this up pretty cheaply. And last but not least, a notable mention, you could probably fit one of these 10 gig NICs into your budget if you were looking to get around the £200 mark. You can regularly find those for about £20 to £30 online. Do bear in mind that you will need a 10 gig switch to take advantage of that, so perhaps something for the back burner and later on in your home lab journey. So for a physical installation, we're going to have to download the ISO. We're going to have to burn that using our good old friend Rufus to a USB stick and install it using the wizard. So with your ISO burnt to your USB stick, do note that you can also install TrueNAS to another hard drive, so you could have 3 hard drives, one which you would use for your TrueNAS install, and then 2 which you would put into a RAID configuration. So with that burned, go ahead, insert that into your machine, boot up and select your USB stick as your boot option. I'm going to do something which I said I don't recommend you do, but it's going to give you who wish to do it as a VM the option to go and do that. And also it's easier for me because I can spin this up. And the main thing is the installation process is exactly the same no matter whether you're doing it physical or virtually. So within Proxmox, I've created a virtual machine. It's pretty straightforward, same as what we've done for other virtual machines. I've simply given it 2 cores and 8 gigs of RAM. I've created 3 hard drives, one where I'm going to install TrueNAS, and then 2 additional drives which will be creating a RAID that will be used then as the main storage and part of my Samba share. It's attached to my default bridge, so it has network connectivity, and that's it. So let's go ahead and start it up, and let's get on with the installation process. So the installation steps are pretty simple. We simply want to hit number 1, install upgrade. We want to choose where we're going to install TrueNAS. So this will likely be your USB stick or another drive that you have available. So in this case, I'm just going to use this 32 gig drive. So I hit spacebar to select that and then hit return to click OK. This just states that it's going to format it. Do note that TrueNAS recommends you use a SATA or an NVMe flash drive. USB sticks used to be the go-to, but they're now discouraged just because they don't have the read and write capability. Now, I would say for TrueNAS, if you're just using this purely for a NAS, there isn't that much that's going to be written to the device, so you're probably going to be okay. TrueNAS Scale, on the other hand, is meant to be sort of more of a hypervisor container platform, so you can understand why a USB stick wouldn't be best suited for that. But just go ahead and continue with the installation. We want to create an administrative user. Create a password. Once you've done that, it's going to continue to install. And once you've completed the installation steps, you just need to remove the installation media and reboot. Don't worry when you see this, you have installed it correctly. It's going to auto boot into TrueNAS within 10 seconds. And once the first boot has completed, it's going to run an update, so it might take a while, but it should be given a DHCP IP address, or if you haven't yet connected to your network, go ahead and do that and it should pick up an IP address. You'll want to find that IP address so that you can then jump into the web GUI, which is the bit we'll be covering next. So once that's done, you can see the IP address of your TrueNAS host if you have it connected to your network during installation. So let's go ahead and log into the web portal. So here we are, we've successfully installed and we're able to reach the web GUI. So let's go and log in using the admin credentials and the password we specified during the installation. And when you log in, you're greeted with the dashboard. Now, get used to this dashboard, it is configurable, but it gives you some really handy information about the state of your TrueNAS installation. So you can see here, we've got the CPU usage, and it's good to see that it's idling because we're not actually doing anything on here. You can see that I've given it the minimum of 8 gigs of RAM, and again, because we're not really doing anything, most of that RAM is free and will go into the ZFS cache once we create that. So let's go ahead and create our first dataset. To do that, we're going to have to understand a few things about how TrueNAS works. So, at the bottom level, you have your physical disks. You join these disks together to make a virtual device, a VDEV. Now, you can have multiple VDEVs joined together, and you join those together within a pool. As I mentioned before, we can scale up our TrueNAS installation. So even though you're only using 2 disks now, you could add more VDEVs with a greater number of drives into the same pool at a later date. Or, moreover, you could create new VDEVs and new Z pools. Now, datasets come out of pools as well as Z volumes. So try and think of it that the data set that you're going to consume, i.e. the file share that you're going to be mounting on your systems, is part of a pool, and that pool is made up of lots of disks that are all joined together within various VDEVs. So let's go ahead and create a pool. So when you click create a pool, it says on the left here that I've got 2 drives available. And that makes sense because I created my Proxmox VM with 2 drives, and that should be the same for you if you're using 2 drives or however many drives you have left available that aren't in use by the root file system, i.e. those drives where TrueNAS isn't installed. So let's select those 2 drives and create a VDEV. So we click this arrow here. We can now choose what type of VDEV we're going to use. So on the drop down, we've got a stripe. So a stripe is going to extend those devices, so it will be additive. So you will have a single device that is 40 gigs. But I don't recommend that, because if any one of those two drives fails, you're going to lose all of your data. Now, that's a little bit different in a virtual setup, because like in mine, I've already got 4 drives in a mirror. So the likelihood of that failing is pretty low. But in your physical setup, if one of your hard drives were to fail, you would lose all of your data. So I recommend we're going to go with the mirror. We're going to select both of those drives. We're going to give it a name. And then we're going to hit create. You can choose to encrypt the drive as well if you wish. You can also do this at a later date. It's up to you. I'm not going to cover that in this video just because we're not going to need it, and there's a few more additional steps. Plus, you'll have to make sure that you keep your encryption keys safe and all of that, and I'll save that for another video. So let's go ahead and click create. You want to confirm that you're happy with that because it's going to wipe those drives. Should be pretty quick to create the pool, and once it's created that, we should be able to see that pool created. So here we have an overview of all of the storage on our TrueNAS, and as you can see, the one we've created is a mirror. It's 2 wide, it means it has 2 disks with a total capacity of 20 gigs. That's because we're using a mirror, so both drives are exactly the same. That means we don't get 40, we get the capacity of a single drive. However, we get the performance of 2 drives, so that's really good. And that's another reason why you may wish to go down the 10 gig route, because even a single hard drive is going to saturate a 1 gig Ethernet port, i.e. that's going to give you 100 megs per second it's going to cap out at, but your drives can probably do at least 200 on a read each, and if you're adding them together, you're likely going to be hitting more like 400 megs per second. So you can see that after TrueNAS has done its magic, a bit like when you format a normal drive, you've lost a bit of storage, so out of a potential 20 gigs, we've ended up with 17. It's showing us that the health of the drives is good. That's one thing you'll want to double check if you've got second-hand drives, for example, or you've had drives that have been lying around for a while. Make sure that those health checks are good, otherwise you're going to want to replace that drive. You don't want to be putting data on damaged drives. So now that we have the pool created with the VDEVs, we want to go and create a dataset. So that's really simple. We simply go to datasets on the left, and we click add dataset. Now, if you had more pools available on the left hand side, you would see all of your different pools. We only have one, so this is dead simple. So we click add a dataset. We're going to give it a name. You call it whatever makes sense for you. I'm just going to call it my first dataset. I'm leaving the default options for the compression level. LZ4 gives you a good level of compression and is also very performant. And then I'm going to click save. So now on the left hand side, you'll see within that TrueNAS root folder, we've got my first dataset. So this is great. This is a dataset now on TrueNAS that we can go and save files to and from. You'll notice on the right hand side we can set up all the permissions that we want. I'm not going to get into that on this video, but it's very similar to how any Linux permissions work. You create a user and you tell it what you want it to be able to do. So you can tell it to give it read, write or execute, and you can say whether you want the user, the group or world to be able to do that. The next thing we want to do is, if you're going to want to use this more broadly on your network, you want to create a share. Now, that's the next option down handily, so we'll click that on the left. And you're going to have a few options. You can create a Windows SMB, that's a Samba share, which you're probably quite familiar with. You can create an NFS share, which is typically seen in Linux. Or you can even create a SCSI share, which, if you go into Proxmox, I mentioned in the video earlier as well, you might want to boot devices from your TrueNAS. So iSCSI is a bit different, as in it's not a file share, it uses block level storage. So a machine will see that as a physical device effectively, as opposed to a file share. So for this video, and because SMB is easier to work with and has more granular control around permissions, I'm going to create an SMB share, even though I'm going to be using that on Linux. So we want to click Add on the SMB share. And we want to choose what we're going to share. So we're going to share that first data set that we created. We're just going to give it the default share permissions, and we're just going to hit save. It's going to ask you if you want to start the SMB service. Obviously we do, otherwise we won't be able to access it. This is where it's going to give you the granular access to the permissions list and what you want to do. I'm going to leave that at default for now, but it's pretty straightforward. You create users and you assign permissions. So let's save the access control list. And perfect. We've got the SMB symbol there next to our dataset, and it says that it's got the SMB role enabled. So that means now we can access our TrueNAS SMB share from any of our devices on our network, provided that we give the right credentials. So let's go ahead and do that. So in order to access our SMB share on Windows or Linux or any other machine that can access a Samba share, we're going to go and create a non-root or admin user, and we're going to assign read, write and execute permissions to that user on our share. To do that, we want to click on the Credentials tab on the left, and we simply want to add a new user. So name your user, give them a password. You can leave everything else the same or configure it as you require. We don't need to change anything for the sake of this tutorial. So we just go down and we hit save. So now we can see that that user's been created. It's got a UID of 3000, and we can verify the name. We can see that it requires a password, and it's used for Samba authentication, which is the share we created. So let's go back to our dataset. Click on that, and then let's edit the permissions. Now we want to add an item. We want to click on the mask. We want to drop down, and we want to select that this is a user because that's what we've just created. We want to look for the user we just created. In my case, I called it user 1. You put in here whatever you called your user. And for the sake of this, I want my user to be able to read, write, and execute files on that share. And then I need to save that access control list again. So now that that's saved, we should be able to go into our Windows Explorer or Linux or wherever you are. You can even do this on the command line. And we should be able to mount that share using the credentials provided. So let's go and try that. You're going to want to map a network drive. You can choose the drive location that you want to use. Mine's defaulted to Y because I'm already using Z. And for this, you'll see the format is //server/share. Now we want to do // and then you want the IP address of your TrueNAS installation. In my case, it's 192.168.200.188. And the share name, I called mine my first dataset. So whatever you called your share name. One thing to note is if you don't want to have to remember the IP address, in our previous video with Pi-hole, you could actually put in an internal DNS name there, so you could have truenas.local or whatever you want to do. World's your oyster. The key thing here is that when we try to finish this, we want to connect using different credentials. So we don't want to use the credentials that you're using for your Windows installation. So it's now going to ask us to put in our credentials. Now these are the credentials you just specified when you created the new user in TrueNAS. So mine was user1, and I put my password in. I want to save this so that every time my computer boots, it's going to log in and automatically mount this share. So let's hit OK and see what happens. And there we have it. We see down here my first dataset is mounted to my PC. I can now create a new text file. We'll just call that test. Let's open that up. Let's write some text. Let's save that. Let's close it down. Let's open that up. And as you can see, the text is saved into that file. It's behaving just like a folder would on your normal computer. So let's go ahead now and connect to this file share through Linux. That will mean that we can access and validate that that file was written, and also it gives us confirmation that all the systems on our network will be able to write and read to this drive. So in order to mount our SMB share within Linux, log into your Linux machine. I'm going to assume it's your Docker VM at the moment. And you're going to need to install a prerequisite. So first of all, you need to install CIFS. This is an application that you can use to mount SMB shares. So it's simple as sudo apt install CIFS-utils, and then we can put -y to make the prompt disappear. Put your password in. Once that's done, you're going to want to make a folder where you will mount your share to. So that's a bit different to Windows. So let me walk you through that. So let's change to our root folder and let's make a directory. So sudo make dir, that's make directory. Let's say /media/share. Okay, that's created. So there are two ways you can mount this. You can either mount it for now, i.e. this session, or you can actually add it to the file system tab and it will mount it every time you boot Linux. So let's go and do that. We're going to have to nano to etc fs tab. We're going to go to the bottom and we're going to append a new line. And what we're going to need is the location of the share. So this is the same as what we put in our Windows install. We're also going to need the name of the share as well. So mine was my first dataset. We're going to have to tell it where we want to mount that. So we did /media/share, but you can do it wherever you want. We're going to tell it that we need to use CIFS, which is the application we just installed for mounting the Samba share. We're going to mount it with our current user, which has a user ID of 1000. We're going to put in the username as our user that we created within TrueNAS. In my case, that was user1. We're going to put in the password that we chose. Mine is a super secure password, as you can tell. And we're going to put a couple of additional options that give you better compatibility with Linux. So that's _netdev /0/0. And then we're going to save that. So click Ctrl-O and return. Great, that's written. And now we should be able to do sudo mount-a. And then if we change directory and go to our /media/share, fingers crossed, we should see our text file. And voila, we do. So let's cat that. And there you can see the text that I wrote on my Windows machine. So there we have it. We have an SMB share that you can now access across all of your devices that support SMB. So if you've managed to follow the guide so far, we've just hit another major milestone in our home lab journey. Now we have a full-blown Proxmox server, we have a Docker VM, we have a firewall, we have container-based security tools with CrowdSec, and now we have a NAS. So it's time to start using that NAS and get into some more complex setups. In the next video, I'll be showing you how to set up your very own media center with Plex and Jellyfin. See you on the next video.